Okay, gang. I'm going to really try to make a good video. That doesn't mean much to you, does it? I'll set the stage for you. This is the tender that I had been working on that was working fairly well. And I had some issues that I wasn't happy with. With this drawbar. The drawbar actually came out nice. But as try as I might, you can see it gets tight in there with that magnet sticking out and all that, plus the screw that's going to hold that on. And I could hear it clicking and every once in a while dragging. I also wasn't real excited about the exposed method of this reed switch. The reed switch is actually glass, and it really can't get, it can get broken easily. So exposed like that, even though it's encased in adhesive that's cured, the UV cured adhesive, it's still risky. So I went to the drawing board earlier today. Let me turn off this light again. There you go. And I made some modifications to this particular part. As you'll see, this is the normal part. And the differences here is this has been pushed out now. In the last piece, I actually made a snout that I screwed into this part and extended it out, and that that made the thing work. But I didn't have a magnet, and by putting this here in the original position, there was still a blob that would have hit the magnet. So this might have worked, but I didn't trust it. So I thought, heck, I'm going to create a very special piece just for this train, this combination. And so I've extended this out. So now the insert will be out further, about 8 millimeters. I'm going to extend all of this out. I'm going to leave this, obviously, because that's the clearance for the roller axle thing. But what I've added, I'm going to try to show you here, is a hole in the machine, in this fitting here. Let's turn this around this way. Let's get it up here where you can see it, make it a little bigger, and I'm going to do a section review. You'll see this in a second. I'm going to go here, I'm going to come up here and do an inspect, section analysis, and what we're going to do is drill through this in a way that you can see what's going on. I want you to see this hole right here and watch it as I start to drill through this thing. I'm going to start peeling back this. The pink is the cross section. There's the hole. You see it right there. Now that hole is going through the entire piece and coming out right at the axle. You see that hole? So that hole is like a tunnel going right through. I've got a mounting bolt here. I've got the pickup screw here. It's going right between those two screws, and it's coming out right at the point the axle is going to be in front of it spinning. You got it? All right. The other thing I did was I went over to this guy, and this is the axle spacer, and I created a space for the magnet. Before, all I could do with my hand tools was simply file a slot and, try to give myself enough room. But now I had a full depth piece where I can just press fit the magnet, and it would stay in position, and it would be fairly smooth, not perfect, but fairly smooth to the overall surface. So I did that. I did not use that. And I lengthen this piece, and I put the hole in, and then I said, boy, this is all pretty rickety. I wonder if this is even going to work. So I printed a piece, and the hole was a little clogged, so I had to actually drill it out. Didn't have the right size drill, too lazy to go get it, so I just over drilled it. Doesn't matter. For me, I'm going to fix it, reprint it. And if I do have to drill it out, I'll drill it out proper size. But what I wanted to show you is there's the magnet in its new piece. Hear that beep? That's the trigger getting triggered, okay? And how reliable is that? Oh, I'm sorry, I was showing you my finger. I said I'd do better. Okay, I saw it. I fixed it. There it is. Every time I rotate that, in that position, it triggers that magnet. Every time. Now what I'm going to do is I'm going to cut that wire off, probably put some flexible wire on it, because in the chassis, just to the side, right behind that wheel, there's the outlet going into the PC board. So that's all it has to do. So you can see it's going to come out in about the same spot as it did, except it's going to come out low. Actually, it's not going to come up and over. It's just going to come right out and go down. So that loop is going to be a little shorter, but it's going to be more effective. And the part, I think, is going to work. And there won't be kludgy gluing in space, praying to God, and things getting in the way. I'm going to get rid of every possible chance of screw up. This went together like clockwork. It's beautiful and it works. This did not. And I fell down. I wanted to get it built. I wanted to test it, and I did. Okay, fine. Not happy. Couldn't sleep. It's terrible. Now, thought about it, came back in. I've got this solution. I don't have time to print another part, but what I may do is go ahead and use this as a proof of principle. I may go ahead and assemble this and build this and replace it and verify that I've got the clearances right, the locations right. I need to shorten this drawbar by 8 millimeters and use the longer tab. I got to print that part. I won't have time to do that today, damn it. Okay. I can probably print that part, but I won't have time to build it. I'll do that tomorrow, I guess. But I think that then puts it to bed, finally. Because it's working so well. I couldn't have one thing that just is crap or not as good as I could make it. And I thought, come on, you can do better. I don't know. There's no room. Well, find a way. This thing with insulation and everything is like 3-4 millimeters. There's no room. I put in a 2¼ millimeter hole. I'm putting it in bare, and I'm doing that because it's going to be protected by the plastic. Then all I need to do is tack a soft wire onto that lead, trim this lead back, put a soft wire on it, and run those 2 wires through that hole you saw in the chassis frame. And it doesn't need insulation or protection. It's going to be fine. I could run a sleeve on this upper piece to keep that piece from getting shorted somewhere, but there's no contact, there's no screws, there's nothing that's going to get in the way. That's not true. There's a screw there. Okay, I'll put the sleeve on it. I'll put the shrink tube over it. That'll protect it. We'll be okay. And that's going to, and this is where I was doodling. I get these crazy things. I try to put them in here. I said, how can I do it here? How can I do it here? I said, well, I can't really draw it the way, so I built it. And this is almost, when you're doing this, I'll say okay with that. When you're doing this, it's almost like a simulation. You can move things around. I could move the hole, angle it different ways. I had to really finagle. The hole needs to go in on a flat surface. As you can see, this flat surface, if I put a hole in it, would have been way over here. And maybe I can do that for you, and you can see what happens. Oh yeah, look. Let's lengthen this out. Okay, there. Now let's look at it from the top. The top of what? Okay. Now if I just use that surface, that hole just shoots off, and look, it's nowhere near where I need it, right? So cancel that. What I had to do was to come in here and call a chamfer or an angle for this thing. I was going to relocate it and move it based on a position. So I say move copy. I come up here, I got a face. I'm going to do a rotation. Now I'm going to select the angle, and I'm going to say, let's make this the anchor, and watch the blue, I'll shut this off again. Watch the blue piece. See how it starts to come out toward you? I can change the angle of that part. All right, let's just do it there and see what happens. Oh, it's too much. I know it is. I know what I know what I did. I think it was about there. Let's try that. All right. There. Now let's put a hole in it. Boom. Oh, look at that. Look at that. That's it's still off, but it's close. But you can see, you can almost play with this to determine the angle that you need and how you're going to do it. Cancel that. So I went in too far. I kind of knew that. I knew the number should have been 6. I made it a 7, so I'm way over. So if I make it a 6, it'll come in like this. And it should actually, if I make it the same angle, should intersect, right? Because this is the angle this piece is here. Oh, look, you can see it. When I hit here, it lights up all the area so you can see right where it goes. Barely touches here. Barely. I just sneak it right in. Now, it's a little tight. It probably shrank when it was printed, so I'm going to have to enlarge it slightly. Maybe I'll go to 275 or something like that. I may still have to clean it out. I don't know. But I'll get the right size bit, and I won't go over and all. And it doesn't matter. I can make it a trough, frankly, but I don't want to do that. I want to have it protected. So, anyway, that was my afternoon. Fixing this thing so that this can go together easily for all you guys. And I think it'll be a good thing. I think it'll be okay. And that's what I did. And it's 5:30. Oh boy. Okay. Printer's working like a champ. CAD system, new PC's working. This new CAD system is working great. That's how you slice the part, what it looks like when you go to print. You can see the hole right there. Okay, well, that's what I got done. You're not going to see anything fun, just other than that noise thing. That was sort of like a show and tell, but I guess not so hot. But at any rate, okay, that's it. I'm done. Have a good day. I tried to make my video better and show you something useful and interesting and how things get done, kind of. Okay, later.